We're here to talk about the challenges organizations face today as they try to orchestrate transportation, manufacturing, warehousing, distribution across an extended global supply chain. And as we all know, today's de facto standard for communicating status updates on shipments is primarily EDI. And I think this diagram does a very good job of illustrating the challenges associated with that model. In this diagram, the journey of a conveyance is represented by the blue line. The actual location of the truck, airplane, ocean vessel is represented by the dark blue dot. So when a consignee receives a shipment status update via EDI from their carrier or 3PL, they believe the shipment is at the point in the journey represented by the green box. But because EDI status updates are notoriously latent, they're oftentimes well off the mark. In some cases, the shipment is past the point at which they believe it is. In some cases, it's behind where they believe it is. These latent status updates and the extended blind spots are the bane of a supply chain professional's existence. There's no way to confidently plan downstream supply chain operations or to quote accurate estimated times of arrival to customers when you don't know where your goods are right now and you don't have confidence about when they're going to arrive. Now, worst of all, what happens when a shipment encounters an unanticipated disruption, as represented by this red triangle here, such as severe weather, traffic delay, port congestion, or even an unscheduled stop at a port? Given the latent status updates, the consignee doesn't find out about these issues until well after the fact. And by then, the supply chain manager's options around remediating the situation are significantly limited. So how do companies offset this uncertainty today? Well, they do it with buffer stock, oftentimes having to expedite shipments, rushing orders, and offering customer discounts in the cases where things go wrong. So specifically, how do these challenges impact operational performance? Without real-time visibility and tight coordination on the inland move, for example, from a foreign supplier to a port, delays often occur when shipments miss the cutoff window to be loaded onto the vessel. And when that happens, the goods must be held at the port by the forwarder until another vessel on that shipping lane becomes available. Another challenge, within that point of the journey is orders being shorted by the supplier. Beneficial cargo owners often don't find out about short orders until they receive the shipment at their final destination and open the box within their domestic warehouse. On the international leg, the second orange bar here, BCOs often struggle when shipments are delayed due to severe weather, port congestion, natural disasters, unscheduled port stops, as I alluded to before, prolonged customs clearance times. BCOs have no way to predict and avoid these disruptions. Furthermore, shipment ETAs provided by carriers are highly variable and oftentimes inaccurate, in large part because the carriers themselves have no way of factoring in the impact of these unforeseen disruptions. And given these challenges, BCOs can't confidently schedule drayage or plan downstream supply chain operations. They can't commit inventory in transit, and they need to hold excess buffer stock to offset all this uncertainty. Now, on the domestic inland leg, for example, BCOs can't foresee and avoid supply chain disruptions such as road construction, traffic accidents, and they often don't have real-time visibility of the truck moves. Nor do they have very accurate ETAs for shipments arriving at warehouses or manufacturing facilities. So with all of this uncertainty, BCOs have difficulty managing JIT manufacturing, as well as efficiently scheduling docks and labor schedules at their warehouses. Now, finally, in the last mile here, BCOs struggle without real-time visibility of the shipments because they have a hard time hitting customer delivery windows or providing accurate ETAs to customers. So that's kind of all under the traditionalist model, under this EDI, network of networks model, if you will. Now enter a new approach. Innovators have found a way to track shipments in real time, using live locations of aircraft, ocean vessels, trucks, rail cars, parcel shipments. In this world, supply chain professionals know exactly where every order, item, and shipment is right now. And when you know that, your confidence level goes way up, and you can do all kinds of special things. You can confidently plan downstream operations such as drayage, dock scheduling, labor scheduling, manufacturing scheduling. You can confidently commit inventory in transit and provide very accurate estimated times of arrival to customers. Even when there's a disruption, Innovators are alerted to these disruptions immediately and can remediate the situation with many more options at their disposal. Innovators with this approach are transforming the way supply chains operate. Now, futurists take it a step further. Futurists don't just have the ability to track the live locations of conveyances and packages, they also have the ability to track and monitor the myriad external events that could cause a disruption. These are things like weather, port congestion, road traffic, customs clearance times, labor unrest, to name a few. And they're not just monitoring these events in real time to understand what's unfolding right now, they're applying advanced analytics and modeling what events are going to happen in the future. If I know the precise location, speed, bearing, and final destinations for every ocean vessel on the sea, for example, I can confidently predict which ports will experience uncommonly high congestion several weeks in advance. By predicting disruptions in the future at a very granular level, I can make optimal decisions that avoid the disruption in the first place, and that is transformational. The strategic and operational impacts of all these things that I've described are significant. So, organizations can now confidently commit inventory in transit using global inventory in motion, something that supply chain professionals have been dreaming about for a long time. They can effectively coordinate shipment handoffs between trading partners across modes. They can track and forecast the arrival of critical parts. They can begin competing with same-day delivery competitors like Amazon, who are becoming vertically integrated and have ambitions to disintermediate many brands. And they can tighten up cycle times, reduce costs by orchestrating downstream supply chain operations in a just-in-time fashion. So how does it all work? Well, it all starts with the real-time big data, lots of it. So we're collecting, cleansing, and processing over 1 trillion real-time big data events around the world every day with IoT devices. Okay, this data is then analyzed by our advanced machine learning algorithms, the output of which are live and predictive insights about potential disruptions, about optimal routes, consumer sentiment, accurate ETAs, etc. But in order to translate these insights into business value, they must be executed, or what we like to say is drive intelligent actions throughout the organization. And at this point, this whole point about the intelligent actions, this is a key takeaway for the webinar. The criticality of tight integration and orchestration between a predictive analytics solution like TransVoyant and a supply chain planning and execution system like JDA. And of course, it all needs to be supported by world-class data scientists, a resource in today's talent pool that's pretty scarce. Since the data itself is so important, let's just talk about that in a little more specificity. First, how can an analytics solution be a complete solution if it isn't coming to the table with the data itself? And I'm not talking about historical data streams that would be maybe analyzed by a BI tool. I'm talking about real-time data streams around the world every day. And what are some of these data streams? Well, these are live aircraft, vessel, truck, rail car locations, the behavior of ports in real time. These are temperatures, wind speeds, wave heights, natural disasters, geopolitical trends, media articles, social media, massive amounts of real-time big data. And from where are we collecting this big data? As I said earlier, from IoT devices, things like sensors, RFID, satellites, radar, smartphones, drones, social media, process control devices, right? And the real-time big data streams, in an analogy, are kind of like raw materials feeding into a factory. So on the left-hand side of this diagram. And the various machine learning algorithms that are processing the data are like line schedules that produce the powerful insights rolling off the end of the production line as finished goods. So, what are detailed examples of these insights and how do they flow seamlessly between supply chain planning and supply chain execution? My apologies that this slide isn't more visually rewarding, but the table gets the point across. In the first example listed here, JDA planning calls for parts to be purchased from our primary supplier in Malaysia, to be shipped from the supplier on May 3rd. Now this plan flows into TransVoyant, which determines through social media and traditional media monitoring, as well as other economic indicators, that there will likely be a labor strike at the supplier in Malaysia during the time JDA planned to source the parts. So consequently, TransVoyant recommends sourcing from our secondary supplier and passes that insight into JDA for execution, at which time JDA changes the PO and replans the transportation. Now, as we move down the line here, JDA TMS arranges for an ocean shipment for this part, calling for the shipment to go from Nagoya to Long Beach on May 4th. Once again, this plan flows into TransVoyant to be modeled with our predictive analytics, and TransVoyant determines that there will be 18-foot swells halfway through the journey on the planned ocean lane, which will cause a delay. Furthermore, by the time the vessel is predicted to arrive in Long Beach, TransVoyant knows how many vessels will be arriving at that time and predicts 3 days delay due to port congestion. Consequently, TransVoyant recommends an alternate lane, Nagoya to Oakland, which will avoid both delays. So ocean ship it into Oakland and then truck it down to LA. So JDA then adjusts the plan and books the new carrier from an execution perspective. Now, as the shipment is on the water, TransVoyant is tracking it in real time, and it sees it deviating from its planned course at a point in the journey, which we've been watching for years, and we know exactly what that means when a vessel starts to tack at that point in the journey. It means it's going to make an unscheduled stop at a port that was never on its schedule. This happens certainly more than carriers like to admit, and anybody that does a lot of ocean shipping knows it happens more than they'd like to admit. So TransVoyant recalculates the new ETA for that shipment, which is now 3 days later than originally calculated given the unscheduled port stop, and it passes this insight to JDA. Then JDA adjusts the dray carrier pickup schedule and the manufacturing scheduling, knowing that the parts are going to be delayed by 3 days. So finally, as we make our way down to the bottom of this list, TransVoyant determines from social media monitoring that interest in a particular garment style is trending much hotter in the Southeast than in the rest of the country. This real-time demand signal is passed to JDA, which adjusts the inventory allocation for that particular style to ship more to the Atlanta warehouse, and JDA also arranges the transportation and sets the dock schedule to receive that additional stock at that particular warehouse. So these are just a handful of examples of how JDA and TransVoyant work together and the transformational value that comes from that orchestration. So now I'd like to hand it over to Fab, who will walk through a few more detailed examples in the TMS realm. Fab?
Great. Well, thank you. There's a couple of things, before I begin, there's a couple of key things that I want to be able to echo based upon what Scott just went over. One is, this is more than just point visibility. We're really talking about insights here. So the real important factor is the collection of multiple streams of data to provide not just a location or even an ETA, but something that's actually predictive based upon multiple things happening within the network. And then the second point, which is really what I'm going to focus on, is the importance of having taking that intelligence and turning it into something actionable, right? Actually being able to react, or in many cases proactively be able to utilize that information to make better decisions. So in the context of transportation, as an example, if you think about transportation planning, right, most of us have worked with TMSs in the past, and there's always, some sort of planning function where we take a number of orders or moves that we have to execute across the network, and we create a transportation plan. And the reality is that there's a gap between what we think the plan is going to look like or how it's going to execute versus what actually happens. In a lot of cases, we try to get pretty close, but clearly there's a lot of things that can happen within the network that we can't particularly predict that may affect the end result. So the way transportation solutions work today is, much like our own, we'll model as much as we can. So we'll model things like location throughput, we'll model asset capacity, we'll model transit times, and we'll try to get to as close to a real representation of the result as possible. But again, there's a lot of things that can possibly happen. As some of the examples that Scott talked about: traffic congestion, weather, port delays, congestion. So the question then is, can we take that information and not just react to it, but can we take that as an input, potentially, if we can find out soon enough, and use that to change the plan in the first place? And so it's our contention, and what we've been working with TransVoyant on, is really to be able to do both. So to be able to react to things, things like revised ETAs or more accurate predictive ETAs, and be able to react accordingly, possibly reroute or change destinations. But also, can we take inputs that maybe allow us to affect the plan in the first place, so that that initial picture gets even closer to actual realization? So as Scott pointed out, on the TransVoyant side, there's a lot of things that go into creating those insights, right? So it's all the raw data, all of the in-house algorithms. And the key thing, again, is instead of calculating or just providing point visibility, we're really creating these insights and predictions. And the workflows that we've created, and I'll demonstrate just a handful of them, really looks to take those, and as I mentioned, really look at those both from a reactive as well as a proactive point of view. So they come into our transportation paradigm, which encompasses both planning and execution, and depending upon the type of insight and of course the timing of it, right, we'll be able to take that and then proactively create a resolution to it. So if we're getting a revised ETA, which implies something is already in transit, well, then that gives us an opportunity to maybe reroute, take off a stop, add a stop, whatever it happens to be, and be able to react to that accordingly, as well as to be able to notify, customers of any potential delays in the downstream processes. But if it's something that can happen, that can provide us visibility to upstream, so things like potential weather challenges that might impact my plan in the first place, then I'll take those up front in the planning process and be able to use those insights to do things like change asset types ahead of even the goods leaving the dock. The important thing as well when looking at the combination between TransVoyant and JDA is certainly we're starting in the world of transportation, because quite honestly, when you think about all the different things all the different workflows that we can create, transportation was an easy one to understand. It had low-hanging fruit, and it had immediate value. But our goal is really to expand and leverage these insights across our entire planning and execution continuum. So whether it be looking at social media patterns or predictive weather and how that might impact a forecast, to be able to look at similar types of things and how that might affect replenishment and inventory stocking levels, we're going to look to take that and really encompass it and drive that across the entire supply chain planning and execution continuum. So with that, let's take a look at a couple of simple workflows, again, in the transportation domain. So we'll start off with a dashboard, and in this case, you'll see a couple of violations that have already been highlighted. So we'll start with the first one, which is calling out a weather temperature violation. So in this case, I'll highlight that particular event, and you'll see we pull up a map. And in this case, what the scenario is we've got a truckload that we're planning, that's not in process yet, but we're planning to move, in this case, a consignment of beer from Spain through a point in France all the way up to Belgium. And what this is highlighting is at the red dot, or the red pin, is that we have a weather issue. And we have a weather issue that's going to change the temperature to such a degree that it's actually going to spoil the beer. So that when it gets to its destination, it's not going to be in the condition or have the level of quality that our customers require. So in this case, we're going to leverage the insights that are produced by TransVoyant and update the transportation solution ahead of time to be able to request a change of asset. So in this case, maybe it's a reefer truck instead of an ambient, so that we can make sure that the consistency of the temperature all the way through the load right, remains consistent and the quality of goods are not affected. So this is really an important example because it's not just about, in this case, we're really talking about not just, reduction or affecting transportation costs, but in this case, we're really affecting customer satisfaction. We're affecting, damaged goods or potentially wasted goods, which will affect inventory levels, right, or future inventory. So there's a number of components of supply chain value that are affected just by this simple workflow. And in this case, again, we're getting this message ahead of time so that we're able to proactively make the change prior to the move even being made. So it's really happening during the planning process as opposed to something that's already in transit. The second example here is we've got an alert around high traffic congestion. So in this case, we'll click on this particular event again, and we've got a similar map. And here, we're looking at the same route, but in this case, the goods are already in transit. So this was meant to be a multi-stop load where we'd be stopping at the location in France on our way to Belgium. So in this case now, because of an issue that's arising, and we could be finding out about this across multiple data streams, there's traffic congestion. That's going to really cause a significant delay to our ability to deliver along this path. So in this case, we'll take the update, again, from TransVoyant. We'll do some dynamic replanning. And in this case, we're going to make the decision, instead of making both stops late because of the traffic congestion, we're going to elect to bypass that stop entirely and deliver to the end destination so that at least one of the stops gets their consignment of goods on time and unaffected, and then we'll be able to replan and understand when we can get back to the initial stop that we wanted to deliver to and understand that revised ETA. Maybe the truck circles back so we incur more miles, but at least this time while we may have actually had a late delivery at both locations, in this case we're only going to have a late delivery at one. So that's more of an example where we are reacting to an event along the path, being able to make the change and make the best possible change subject to the entire supply chain.